All right, then we come to the next example, still dealing with rules of derivative or shortcut of doing the derivative. Now, this time, what if I'm given y equals to, open bracket, x squared, and then plus 4, close bracket, open bracket, let's say I now have 3x, and then plus the 2. That can be derived, but you need to break the brackets. You need to FOIL it every time you need to do that. We good, ne? So now when we simplify that, it will be x squared times 3x squared. It now becomes 3x to the power of 3. Isn't it right? And then x squared times that 2. Yes, it becomes 2x squared. The 4 times the 3x, it becomes the 12x. And then the 4 and that one is now plus the 8. So you need to get it here first. And you now know how to derive this. We good, ne? All right. So I'm not going to do it in that one because you're deriving this one. All right. Anyway, let's do it in case somebody says, hey, maybe I don't know how to do it. Y dash equals 2. 3 will times the 3. We get a 9. X squared. We good, ne? And then plus the 2 will times the 2. It's now 4. X, isn't it right? When it's just x, we know it's just that number in front. When it's without the x, it's just the 0. So this is your derivative. All right. What if then you are given y equals to, maybe it's 1 over the x, and then plus 1, and then the other side, you given x to the 3, minus a half. What do? You do exactly the same thing we did. All right? But watch now. That one there. Yes. You're going to have to fix it. So we haven't derived. Before you derive, the x must be up. You make it nice first. So let's make it nice. This 1 over the x will times this one here. It's going to give me x squared. We good, ne? Because it will be like 1 over the x. That will cancel one of them like that. All right. Then this 1 over the x will times that one there, the half. So it will be minus 1 over the 2x. And then the 1 must now multiply the remaining. The remaining will remain as it is, as x to the 3 minus the half. That's why I'm going to come in with the fractions. Now, this can be derived. The x, that one, that white one, it has the power of 1. You can't keep it at the bottom. You need to bring it to the top. Let's go back what we've been doing. Last time we've been taking the x with the power. When it goes down or up, the power changes the sign. You good, ne? Because it has a minus here. When it goes down, it becomes plus. In other words, we switch the sign. So if it here, this one, if it go up, it will be a minus. We switch the sign. That's the idea. All right. So this one here, the x, when it comes here, it becomes x to the negative 1. So now let's make it beautiful before we derive. So it's x squared minus, if you want to write it as, I love to write it as 1 over the 2 and put the x here by the side so that I can actually see the coefficient. We good, ne? And then plus x to the 3, then minus a half. Now I'm ready to derive. Now, dy all over dx, it's equals to, when you derive this, it's 2x. We now know that. The minus 1 must times the minus half to become a positive half. I minus a 1. It's not 0. It's minus 1 minus 1. It's now x to the minus 2. Isn't it right? And then plus, the next one is easy. It will be 3x squared. The other one is 0. Am I right? Then this is the answer unless we want to leave it with a positive exponent. So that means 1 over, we switch again, am I right? It goes down, it becomes x squared, then plus 3x squared. There it is. This is done. We good, ne? Now, in the next one, I'm going to show you when we're having fractions now. Like how we did switch this one. I need to explain them separately.